Hi, chemistry students. We're on to another chapter. This one's chapter 11 on the mole. And as you can see, measuring matter. You know, we've already talked about the mole. Do you remember back October 23rd, we celebrated Mole Day. It started at 6:02 in the morning and it ended at 6:02 p.m. Does that sound familiar? We had a good mole day. Why do chemists use the mole? Because we use it for measuring very small things like atoms or molecules, formula units, ions, electrons, those kind of things. So I would like you guys to get your notes out if you haven't already and write down chemists use the mole to measure very small particles. The mole, commonly abbreviated MOL, not. Why don't you just add the E on? But I do see MOL. It's the SI unit used to measure an amount, just like a dozen. Again, we've talked about this a little bit, but it's a number of
definition is 6.02 times 10 to the 23rd particles. 1 mole of each element has a different volume and mass. Rounded to the nearest tenth of a gram, sulfur has a mass of 32.1 grams per mole. Aluminum has 27.0 grams per mole. Carbon has 12.0 grams per mole. Magnesium has 24.3 grams per mole. Iron has 55.8 grams per mole. Lead has 207.2 grams per mole. Zinc has 65.4 grams per mole.
So a mole of particles has a mass as well. Let's look at how many particles are in a mole. This says 6.0221367 times 10 to the 23rd. That's a lot of atoms or molecules or formula units. This is Avogadro's number in honor of the Italian physicist and lawyer Amedeo Avogadro, who in 1811 determined the volume of 1 mole of gas. We're going to simply use 6.02 times 10 to the 23rd and not write out that number. It looks like this. It's a really big number. So an Avogadro's number, again, is like a dozen, right? A dozen is the mole part, the unit, and the 12 is the Avogadro's number part. But it's not all that functional. Here I have an Avogadro's number of molecules, which means if I take 6.02 times 10 to the 23rd molecules of water, then I have a mole of water. That's great, but the video showed us then how much does it actually weigh. It has a mass, and that's what we'll be using more in the lab. Water is molecules, as you saw, and here we have atoms of copper or formula units of sodium chloride. Now, how come this is a formula unit and not a molecule? Do you remember? Look at the formula, a metal bonded to a nonmetal. That's right, ionic bonds. So if it's ionically bonded, we do not call it a molecule. We say it has formula units. Okay, so how are we going to use this in class? If I had we'll just round down. Let's say 3 dozen eggs, how many do I have? Well, instantly you might go, oh, 36. But if I had 3 moles of atoms, how many atoms is that? So we're going to write it out in order to do the measurements. Until you're really comfortable with Avogadro's number, it's best to write it down and actually get your calculator out and do the math. It's not too hard. So let's say I have 3.5 moles of sucrose, 3.50 moles of sucrose. I look at Avogadro's number, 6.02 times 10 to the 23rd per mole. Now just remember to write the units in the numerator and the denominator. If I had a centimeter in the numerator and a centimeter in the denominator, they would cancel out and it simply equals 1. Well, just because it's a different word, it makes no difference. Mole in the numerator divided by mole in the denominator cancel out. They equal 1. And that's the name of the game when we do dimensional analysis. We have 3.5 times Avogadro's number gives us 2.11 times 10 to the 24th molecules of sucrose. How many sig figs? 3 in the question, 3 in the product. We do not use the periodic table or Avogadro's number in determining significant figures. They're like definitions. There we go. Moles cancel out, and we say there's 2.11 times 10 to the 24th molecules of sucrose in 3.5 moles. Okay, can we go the other way around? Yes, that's what this is telling us. Now, I don't want you to try to memorize these. I want you to write out the problems and notice the way that the units cancel. Here we have an example of zinc, kind of like we used in the lab when we did the counting atoms lab. We have zinc, and we have a yay amount of atoms, and how many moles of that? Well, you always start by writing what you do have. And so again, in this case, we have 4.50 times 10 to the 24th atoms of zinc. Now, how do we find moles? That's what we're looking for. So what we're looking for must be in the numerator so that our units cancel, atoms cancel with atoms. There we go. And we're left with moles. Do you also remember how to plug exponential notation into your calculators? We use a lot of scientific notation. So remember to look for the EE button or EXP button, maybe a second function comma, or you'll see an EXP near the bottom. Make sure you know how to use your calculator. So 4.5 times 10 to the 24th divided by Avogadro's number gives us 7.48 moles. Again, look at the question, 3 sig figs, 3 sig figs in the answer. Okay, now, are we going to be using a lot of atoms? We will, but we don't really hold them in the lab, right? Because we can't see them. So we're going to be using the masses. Let's review just for a minute. Where does this come from? I look at the periodic table and we find the mass of carbon, or the mass number, is 12. Dalton told us a long time ago that carbon is 12 times heavier than hydrogen, which weighs 1. And these were kind of relative masses, so he called them atomic mass units. What are we going to use in the lab? We're going to mass them out by using our balances, our electronic balances. So when we actually do our calculations and we have a certain amount of grams and we want to convert to moles, we look at the periodic table and we see that carbon doesn't weigh 12, does it? It weighs 12.01115 grams per mole. How come it's not just 12? Do you remember that the mass on the periodic table is the weighted average of all the naturally occurring isotopes of that element? So let's try a problem. Oh, by the way, let's write that down. This is the molar mass. So instead of atomic mass units, which doesn't help us a whole lot, it's a great definition, but we're going to be taking masses in the class in grams, and we want to be able to use the molar mass to convert to moles. So the molar mass is grams per 1 mole. The molar mass of any element is numerically equal to its atomic mass, AMUs, in grams per mole. Okay, so here we go. We have grams, just like you use zinc in the lab. This time they're using copper. So let's write down 848 grams of copper. And we want to know how many moles are in a roll of copper. So there we go. We look at the periodic table. We see on the periodic table the mass of copper is 63.5 grams per mole. I want you to carry everything out 1 decimal place on the periodic table. Next year when you're in AP, you can go to the nearest hundredths. But I want you to go to the nearest tenth. Why did I put grams in the denominator? Notice our units. Grams cancels with grams. So units cancel out, and I'm left with moles. There you go. Voila. 3 sig figs in the question, 3 sig figs in our answer. Not too hard. Now, I really don't want you to try to memorize which way we multiply and which way we divide. Always write down the question. Here we have 0.625 moles of calcium. How am I going to go to grams? I have to look at the periodic table. What molar mass am I going to use? Help me out by carrying out to the nearest tenth only. So I write down the question, 0.625 moles. Go to the periodic table, 40.1 grams of calcium per mole. Again, why is moles of calcium in the denominator? Because it cancels with moles of calcium in the numerator. There you have it. Now we have grams of calcium. So we can actually go 2 steps as well. If I have grams, I can find atoms, but you have to go through the mole. Sometimes we call these 2-step problems. I have grams, I go to the periodic table, use the molar mass, go to moles, and then go to atoms. Now, should I write the answer down here? If I really want to know atoms, am I done with the problem? I am not done with the problem. So don't take the time to write down the answer of how many moles are in 4.77 grams of lead. Let's take it one step further. I know that cancels out, but let's try it again. So let's go ahead and write your problem in 2 steps. 4.77 grams. Go to the periodic table. Grams cancel out. We have moles. Go to Avogadro's number. Moles cancel out, and we're left with atoms of lead. 3 sig figs in the question, 3 sig figs in the product. Let me show you this again in a different way. This is saying multiplying and dividing. Again, I don't want you to multiply and divide. So think about it this way. If I have a mass, in most labs, for small amounts, our masses are in grams. So if I want to go from grams to moles, what am I going to use? Well, the mole, I'm going to put a really big heart here, is near and dear to our heart. Whoops, make that go away. So you can write this on a piece of scratch paper or somewhere on a blank sheet, just as a little reminder. The mole, near and dear to our heart, so we always have to go through the mole. How am I going to get there? If I'm going from grams to moles or moles to grams, what you need to remember is use the periodic table. And again, don't try to remember, do I multiply or divide? You just think about what information's given and then how you're going to make it cancel out. Know that everything on the periodic table is in grams per 1 mole. Grams per 1 mole. Okay? Those are going to be our units. And so if I have mass, I'll end up dividing to get to the mole. And if I have moles, I'm going to end up multiplying to get to mass. But again, don't memorize that. It's not worth it. Just know units have to cancel out. So what if I want to know particles? Particles might be atoms, molecules, formula units, I don't know, ions, electrons, anything really small. These are our particles. How am I going to get there? Have to go through the mole, near and dear to my heart. So to go either way, we're going to use, that's right, Avogadro's number. What is Avogadro's number? 6.02 times 10 to the 23rd particles, whatever they might be, per 1 mole. Okay? That might help you a little bit. Always think about what's near and dear to your heart. Here's a couple of answers. You're done if you want to stop here, or you can try some of these problems. I think the answers might already be in your notes, but here they are. We can go over these in class if that would be helpful. I also have the PowerPoint online if you just want to look at the slides and skip me talking here. So there we go. I think there's one more. All right, we're done. Until next time. Bye.